Let us discuss the analysis of quicksort. See, this is the quicksort algorithm. The quicksort algorithm receives the array A, then its lower index and higher index. After that, it will partition the array based on a pivot element. This partition function will select a pivot item. The role of partition function is selecting a pivot item, place the pivot item in its correct position and return its index. Placing the pivot item in its correct position means if you are sorting the array in ascending order, place the item in the correct position in the sorted order. See, here this is the array, and what the partition function will do is it will pick a pivot item. So the pivot item is 5 and we are sorting the array in ascending order. The partition function will place all the elements less than 5 to the left side of 5, the pivot item, and all the elements greater than this pivot element to the right side of the pivot item. That means if you are sorting the array in ascending order, now 5 is in its right position in the sorted order. This pivot item is in its right position. Then after that, we will call quicksort on this side as well as this side. After placing the pivot item in its right position, we will never think about the pivot item. In the sorted array, it is in the correct position. That's why we are processing the lower index to pivot index minus 1. Okay. So our pivot index is 4. Then in the next call, it is pivot index plus 1 to the higher index. See this side, pivot index is 4. This function, partition function, will return this pivot index. This analysis, it has 3 cases. First one, the best case. We have already told this pivot item will divide the array into 2. If your pivot item divides the array exactly into 2 halves, n by 2, n by 2, then we will say this is the best case of quicksort. We have seen this tree as of merge sort. So in the best case, quicksort is like merge sort. The recurrence equation is T of n equal to 2T n by 2 plus Cn. Cn is the merging cost. Here the cost is cost of doing this partition. Okay, that is Cn. Then it will be, if we follow this iterative method, 2 into 2T n by 2 plus Cn which will be 4 into T n by 2, n by 4 plus Cn by 2 plus Cn, okay, that is 4T n by 4 plus Cn plus Cn, 2 into Cn by 2, it is Cn plus Cn, it is 2Cn. This is our second equation, this is our first equation. Third equation, it will be 4 into 2T n by 8 plus Cn n by 4 plus 2cn. So this will be 8 tn by 8 plus cn plus cn, it will be 3cn. This will be our third equation. If we go like this, our kth equation will be 2 raised to k tn by 2 raised to k plus kcn. Our ith equation will be 2 raised to I t n by 2 raised to I plus ICN. When I is the last equation, the problem size equal to 1. Problem size equal to 1. That is, and we will go for this partition if h greater than L only. If they are equal, that is only one element, nothing to do there. We will say the cost of processing one element is equal to some constant C10. Our T of n will be 2 raised to I T of 1 plus ICN. Okay, that is n equal to 2 raised to I is equal to log n. Okay, our T of n will be 2 raised to I is equal to n into C10. T of 1 is C10 plus ICN, that is log n into C into n. We can say the complexity is n log n. We can say the complexity is big O n log n, because this is a dominating term. Next, let us discuss the worst case analysis of quicksort. Here, your pivot element, if it is the least element in this array, C1 is the least element in this array. If you are selecting pivot item is equal to 1, all other elements are greater than 1, then what will happen? All other elements will skew to the right side. That is, you will be getting a picture like this. Here, the pivot item is set in right position, so no need to think about it further. So we have, after this, we have to process n minus 1 elements. If we are doing partition and again selecting the lowest element, it will be n minus 2 like that, and it will end with a problem of size 1. If you are selecting the highest element, then picture will be something like this. All other elements will be skewed on the left subtree. Okay, it will be something like this. The recurrence equation will be T of n equal to T n minus 1 plus Cn. Cn is the cost of partition. It has to process n elements. Then we are using iteration method. To derive the time complexity, it will be T n minus 2, this one, plus Cn plus Cn, which is equal to T n minus 2 plus 2Cn. It is our second equation. This is our first equation. If we proceed, Tn minus 3 plus Cn plus 2Cn. So this will be Tn minus 3 plus 3Cn. This is our third equation. In general, our kth equation will be T of n equal to Tn minus k plus kCn. Our ith equation will be Tn minus I plus ICN if ith is the last equation, that is h equal to L, only one element. The problem size is only 1. At that time, this will be T of 1 plus ICN. Let T of 1, cost of crossing one element is equal to some C10. Here we will get, if I is the last equation, then T of n minus I is equal to T of 1, n minus I is equal to 1, I is equal to n minus 1. Coming to our Tn, which will be equal to T1, that is C10 plus I is n minus 1 into Cn into C into n. We can write the complexity is big O. N minus 1 into n, we will get n square term, so it will be dominating. We will get the complexity is big O n square. We will say the worst case complexity of quicksort is big O n square. In this case, the array will not be split into two equal halves. The pivot item splits the array in some proportion. Let us assume it is partitioning the array in 1:3. So n by 4th of the elements on one subtree and 3n by 4 elements on the other subtree. Then your tree will be something like this: n, then n by 4 on one subtree and 3n by 4 on other leg, and n 1 by 4th of n by 4, that is n by 16 on one leg, and 3 times of this 3n by 16 on other leg. Here it is, so 3n plus n 4n by 16, you will get n by 4. Okay, it is correct. Then this will be split as 1 by 4th of this, so it will be 3n by 16. Then it's 3 times 9n by 16. 9 plus 3, 12n. 12n by 16. If we add these two problem sizes, we should get this one. 3n by 16, let us divide by 4. Okay, 3, then 4. Okay, 3n by 4. Okay, that is equal to this. Okay, so this is correct, and it will continue. Finally, it will end up with, we are discussing the average case analysis of quicksort. Here the array is divided in a proportion 1:3. N by 4 elements in one leg, one subtree, and the remaining elements 3 into n by 4 elements on the other subtree. It will continue, and this leg 3 into n by 4 subtree has more elements, so this path or this leg has more length. The leg with 3 into n by 4 elements will be finished after the leg with n by 4 elements, because 3 into n by 4 this leg has more number of elements. The recurrence equation is Tn equal to Tn by 4 plus T 3n by 4 plus Cn. Cn is the cost of conquering. Here we are doing this partition. The cost of partition is Cn. Every root node we have to do partition. Then let us derive the time complexity using iteration method. The recurrence equation is Tn equal to Tn by 4 plus T 3n by 4 plus Cn. Okay, let us call this equation 1. Let us replace this n by Tn by 4 as well as T 3n by 4. Tn by 4 will be replaced as T 1 by 4th of this n by 16 plus T is 3 times, so 3n by 16 plus the 4 times of the first term, n by 4, here n comes, so n by 4 into 3, that is the smallest portion. Okay, so n by 4 into 4, n by 16 into 4, so it will be n by 4, Cn by 4 plus this term T 3n by 4. Okay, 1 by 4th of this, so T 3n by 16 plus T is 3 times 9 n by 16 plus 4 times of the smallest term, so it is 12 n by 16 C plus Cn. Okay, if we expand this, it will be Tn by 16 plus 3n by 3n by 16 T 3n by 16, so it is 2T 3n by 16 plus 9T 9n by 16 plus here you have Cn by 4 plus here 12 Cn by 16 plus Cn. Okay, this is equal to, let us concentrate on this term. It will be equal to 16 is the LCM, so 4Cn plus 12Cn plus 16Cn divided by 16 to 32Cn by 16 is equal to 2Cn. N by 16 plus 2Cn. This will be our second equation. What will be our kth equation? In general, our kth equation will be T of n equal to T n by this is 16, so it is 4 raised to 2. Okay, equation number is 2, it is 16. Okay, so it will be 4 raised to k plus 2 into 2 into T 3n by 4 raised to k plus T into 3 raised to k n by 4 raised to k plus KCN. And our ith equation will be ith equation will be Tn equal to Tn by 4 raised to I plus 2T 3n divided by 4 raised to k plus T 3 raised to k divided by 4 raised to k n plus 3 n 4 raised to I 4 raised to I 3 raised to I 4 raised to I, then I Cn. This will be our ith equation. The ith equation will be Tn by 4 raised to I plus 2 into T 3n divided by 4 raised to I plus 3 raised to I n 4 raised to I plus ICN. That will be our ith equation. Okay. Remember the tree. The leg with maximum number of elements is this one, T 9n by 16. Okay, so this T 3 raised to I divided by 4 raised to I n will be dominating more to this equation. Okay, this will be the dominating term. Finally, it will reach problem size equal to 1 if I, the last equation, then problem size equal to 1, and let us assume let T1 equal to some C5. Okay, if I use the last equation, then we are focusing on the dominating term, that is T of 3 raised to I n divided by 4 raised to I. This will be equal to T of 1. 3 raised to I divided by 4 raised to I into n equal to 1, and I will be equal to log n base 4 by 3. This will be your I. On the last level, these legs will be S-hosted. The remaining leg will be this. So our equation will become Tn equal to T of 1 plus ICN. We know I is log n, and we have assumed T1 is equal to C5, some constant C5 plus log n into C. We can say the time complexity is big O n log n. That is, the time complexity of average case of quicksort is big O n log n.